Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael, JSON B.
Oh, we're going straight for B. Yeah,
right.
I
B
agree.
is better.
Yeah, I found that funny. Is that semi-official or is that just a joke?
Well, I remember it was when it was presented, it was discussed, and binary better, nobody knows.
Maybe B like number 2, A and B. But no, I've never saw that discussed.
This option, like this explanation, I never heard of, so I doubt.
Yeah. So, I mean, specifically, I guess we're talking about storing JSON in Postgres and the options for doing so and how you can then use it. We've had a couple of requests for similar things or things in this area. So thank you to the people that have requested those. Where did you want to start?
Well, I would start with discussion of first normal form and atomic values versus non-atomic values, and do you consider arrays, for example, as atomic? And we definitely should touch history and HStore. Well, arrays are supported for quite long in Postgres, both numeric and other types of arrays like text arrays and so on, and multi-dimensional arrays actually. Then HStore, I think it appeared first in 2004, very long ago, almost 20 years ago. And HStore is like key value, and it doesn't support nesting, but it's still very already like flexible. And so arrays and HStore, it already breaks for some understanding, it already breaks first normal form because these values are not atomic. But actually we can argue that, for example, timestamp is not atomic as well. So let's leave this discussion for theory part and focus on practice part, right? For practice, definitely, I would say these values are very convenient and they are not as evil as nulls. Right? And, I mean, they can save your time, not bringing too much issues in terms of unexpected behavior and so on. There are some cases when you have some unexpected behavior. And the most interesting thing, I remember like 15 years ago, I had a talk in Maryland. It was my first visit to the US. And the talk was about how Postgres is good for modern web applications. At the time, Web 2.0 was a thing, so my talk was called like Postgres is good for Web 2.0, and I did some benchmarks for EAV versus HStore, or arrays, doesn't matter actually in this case. JSON didn't exist at that time yet, and actually I was also working on XML. It's yet another data type which you can say is breaking first normal form, but also provides some flexibility in some cases. I think currently it's not the most popular format, but still, it's still there is some development ongoing still. And the thing is that EAV is very flexible. EAV is entity attribute value when you have 3 tables with foreign keys between them, optional foreign keys. Foreign keys is not the biggest problem there. The biggest problem there is that you need to join extensively. So some entity, some attribute, and additional like connection table between them, which contains value, which stores value. And so basically it's like your document, if you had originally XML or JSON document, you shrink to 3 tables. It's very flexible, supports a lot of possible documents, but to construct document back, you need to join all of them, right? And one thing we have storage overhead issue. Usually, a lot of more bytes need to be wasted to store compared to, for example, text representation or JSON representation. And second thing, you need to join everything together all the time. And as my very simple explanation to new Postgres users, you cannot have index on 2 tables. This means you usually, for best performance, you usually want to have everything in one table. Joins are good, Postgres can be very performant in joins, but not always. Nothing can beat index-only scan, for example, right?
Yeah, and so just to clarify, when you're saying you can't have an index on two tables, we mean if you want a multi-column index, you can't pick two columns that are from separate tables.
Right. So EAV approach is like, I would say, radical normalization approach. You normalize everything, you have IDs everywhere, and then you need to index, and then you need to rely on join algorithms. We have three, right? And compared to denormalized state, when you probably repeat some keys and so on, you have worse performance usually. And so both storage overhead and worse performance to extract whole document, and it usually means you need to avoid EAV. So in most cases you would need.
Yeah. I think it's worth even saying developer experience is worse, right? If even to get the simplest data out of, if you're having to do multiple joins, it's just more complex as well. But yeah, I agree that those two are the far.
Well, developers specifically, I've observed several teams who loved the flexibility. It's like with Star Schema for analytical databases. They love flexibility. They can quite quickly develop abstraction in their language of choice, and be very flexible, very good. But then, at some point, when we have billion of rows, we already can feel trouble with this approach. So my talk 15 years ago, I was trying to prove that HStore or XML or arrays is better. So you need to go denormalized way and rely on flexible indexing capabilities Postgres provides. For example, Gin is the very flexible way to index complex data types, and then JSON appeared, I think, in 2014, 13, first text.
I've written it down. Yeah, 9.2 is 2012, but that was regular that was JSON. It's without B, the less good version.
Syntax sugar JSON, let's call it so.
Yeah. Well, actually, if we're sticking to history, should we give a quick rundown of what that included? So we could store JSON. It did some validation, but it was just a blob. It was like a string, basically.
Text, yes. But why was it so, it was success even before JSON-B? Because by that time already JSON became a standard de facto for web application, mobile application. Most pieces of systems started to communicate using JSON. And it was obvious that it's great to support it in database. And also it gave a birth to this movement. Let's eliminate middleware and allow maybe some very thin middleware, like Postgres. We had an episode about it. And so front end can communicate with data stores, Postgres database through some very thin middleware, which doesn't have a lot of logic. And all our logic, a lot of logic goes, for example, React app, it goes to client code or mobile app. A lot of logic is there, and the data logic goes to database closer. And it also gave another wave of interest to database side programming using PL/PGSQL or PL Python and so on. Right. So this is interesting. Indeed, it started roughly 10 years ago.
Yeah. Wow. That's longer than I would have guessed, actually.
Yeah. And then a few years later, JSON-B was implemented, and it has indexing support, right? So it's binary format, which stores keys in ordered form internally, and it supports flexible indexing capabilities. Well, for JSON, you also can index using B-tree and path. So you can use B-tree indexing for some path expressions. So you need to, you can create an index, expressional index, but it should expression should return scalar values, right? It cannot return whole value. Or you need to convert it to text, but it will be not very good. Basically, you can this index can be meaningful only if your query has the same expression as well, right? And sometimes it's good because this B-tree is very efficient and you can use it in some cases. But for JSONB, you can use GeneIndex with some modifiers like JSONB pattern ops and I don't remember, but there is a way
Path
to
ops, maybe?
path ops. Yes. So you can say I don't need I don't need to remember everything. I just need keys and values, and in this case, only limited expressions will be supported. But index size will be smaller, so you can you have choice. You can choose how to index it, right? And Gene is great in many cases. Not often. There are also issues with Gene sometimes, especially with this fast update option, but it's another story. So JSONB probably. What do you think? How much of popularity to Postgres can be associated with appearance of JSON or JSONB? And what's
I think I mentioned I think we did an episode roughly on this topic of, why is Postgres so popular? And I actually assign quite a lot of value to this, but not necessarily for fully technical reasons. I think there are really good technical reasons for it, which we'll go into soon. But I think for marketing reasons, I think MongoDB was doing really well around this time, not so much for technical reasons, but for marketing reasons. And this, as I think we're going to discuss, this didn't put an end to that debate, but it meant people didn't have to make a decision either or. They could store some of the key value data in Postgres and get nearly as good performance or better in some cases. So I personally think it was really important for the trend we're seeing now of people kind of seeing relational databases as cool again, or the de facto again. I think we were at risk of losing that or losing traction there, and people going more towards databases like Mongo. But yeah, I don't know what. I think it was very important, but I'm not sure.
Right. Likewise, I think it's important, and it helped to join two worlds, right? So relational and non-relational world.
Yeah.
And now everyone who wants to stay in JSON world can just have a table with like surrogate key, big integer, and JSON like data, right?
No, don't give people bad ideas.
It's but of course I don't encourage. Usually I say let's understand which columns we can say. We know these columns and we know data types and all constraints, and we should extract them and store separately and have JSON only for some like flexible, not yet understood parts of our data. But worth mentioning that some people, for example, Oleg Bartonov mentions that usually in his slides at conferences, he mentions that he shows some graphs that showing that when JSONB appeared, popularity of Postgres started to increase. But if you look closer, actually, popularity started to increase slightly earlier. It's the same. It was the same year, but JSON was not yet released. It was released in the end of year, but popularity started to go up earlier that year. It was 2013, maybe 12, 13, I don't remember. And as we discussed in the past, we suspect it was related to RDS probably. Support of Postgres in RDS.
But back to JSON, I think before we move on from the comparison of JSON and JSONB, I have seen some very smart people making a case for that. There are some use cases for JSON over JSONB. There's a few things. You mentioned ordering. If you really want to store what you were sent, for example, for some reason, JSON it preserves the order, it preserves white space, it even preserves duplicate keys. And there's one more advantage I saw somebody share, which is on just purely on ingest rate, it is faster. Mm-hmm. Yeah. So if for any reason those are important to you, it can be useful, but it comes at a big cost in terms of if you need to read the data. So I think for most people, they want to access this data in some way in the future, you're probably going to want JSON-B.
Yeah,
I
think default choice should be JSON-B, but in some cases, indeed, when we need faster insert and we don't care about like better check of better validation in terms of like duplicate keys and so on. Also, regular JSON is takes roughly 2 more space, right? So than JSON-B, and like I don't know. No, vice versa.
Less
sorry.
space, right?
Yes, vice versa.
Unless you count white space.
Yes, it takes less space than JSON-B. So if like default choice is JSON-B, but if you want to optimize on insert speed and on storage space, probably like older JSON data type is better.
Basically, there are some differences. If these kinds of things are important to you, look into it, test it. But that's why if you read up on these topics, often people are just defaulting to JSON-B and not really even explaining why.
Well, because for example, the speed of accessing particular keys will be slower, especially if you have a lot of keys, nested structure, and so on. In JSON-B, it's easy because it's already parsed. But for JSON, it will be Postgres will be parsing on the fly, trying to extract your part of your value. So it depends on workload, right? But I would say go with JSON-B and only in some narrow cases consider JSON, regular JSON.
Cool. Continuing with history, should we talk a little bit about the JSON path stuff added in? It's only a few years ago, 2019, I think, version 12.
Right, and not everything was added. There is first of all a whole part in SQL standard right now, similar to SQL XML. Now there is SQL JSON, and the JSON path. It's a lot of stuff appeared there. Well, before that, I would say Postgres already had a lot of manipulation capabilities, like a lot, and it's hard to remember all of them. For example, you can switch from relational data back and forth, aggregation, accessing particular parts, also changing particular paths. But it was done in native Postgres way because no standard existed. I think Postgres pioneered a lot of things in this area before even commercial databases, right? Yeah. And when standard appeared, a lot of efforts were done to develop support of standard, but unfortunately not everything was committed to recent Postgres versions because it's a huge work and it needs more time for testing and so on. So only parts of that went to Postgres 15.
Yeah, fingers crossed for future versions. I know a lot of people are excited about that. And on the functions front, I think you're right. I think I don't even try and remember them. I don't use it that much, but my general rule of thumb is if you want to manipulate your data in some way and transform it in some way, there's probably a function for that. The docs are great. I'll share a link to them in the show notes. But there's a serious list. So if you think something might be possible, check because it's probably a function that's already there.
Right. I worked with JSON a lot in Postgres context and not only. And I always have reference Postgres documentation open because it has a lot of stuff to cover. Also, speaking of SQL JSON, of course, we need to recommend Oleg Bartonov and others, Alexander Korotkov, Nikita Glukhov work. They had a lot of presentations, a lot of slides. I think we can link them, and there is a lot of work there done over the last few years.
Yeah, a lot in terms of performance and indexing, especially, I believe.
Well, not only indexing. I mean, support of SQL JSON standard, even if it's not fully finished. Yes, it started several years ago. It's like a lot of work. Go check out. But indexing, yes, the same people also involved into Gin support for JSON-B. Indeed.
Rum or vodka? I forgot what it's called.
No, rum vodka is different. It's extension of Gin. Rum is Yeah. So the problem with Gin usually is that you have Gin, okay, you indexed your document, for example, JSON, doesn't matter, maybe something else. Gin supports various things, for example, arrays as well, right? And okay, or full text search, so also Gin. So we indexed some document, and we have a huge table with, for example, ID, created at something else, and this data value indexed by Gin. And then we want to have an search covered by Gin, supported by Gin. But we want to also to have some pagination and order by. Order by, we usually want to have not like traditional approach with full text search. Full text search, why I mentioned full text search? Because Gin originally was created for it, for full text search. Only then it was propagated to complex data types with RD3, Russian doll 3 for arrays and so on. It's a historical knowledge, right? So usually we ordered by some relevance metric. For example, this document is most relevant for this search and goes to the first place, and so on. And this data is like an index. But in social media use cases, we usually order by time. Right, we want
latest or something.
Fresh data go first, old data goes last, and pagination. How to do that? We need to order by either ID or created at timestamp, and this data is not present in Gin. And this is a huge problem because Postgres now needs to choose what to use, either B-tree for that, historical ordering, right, or Gin for full text search or JSON search, anything. Trigram search, it can be anything. And how to combine it? The idea, let's combine it, is a RAM index. So integer or timestamp value goes to Gin, it extends it, and we have the RAM index. But RAM index, in my tests, honestly, I didn't do it in the past 2 or 3 years. So there might be improvements, but in my tests in the past, I had so big index size and performance issues, so I decided not to go with it in production every time I tried it. Maybe today it's better, I don't know. If our listeners have fresh data about RAM behavior, please comment, let us know. It's interesting.
Yeah, that'd be cool. Should we move back to, I feel like we haven't really even discussed when it isn't a good idea. There's some really good articles about this. My personal favorite is by the team at Cybertech. I think Lawrence goes into great detail on a lot of, actually focuses mostly on mistakes he sees people doing. So as we said, very popular. People like the idea of the flexibility, but he listed a bunch of things that they often do that he wouldn't advise, and I think they're very sensible suggestions. Like, for example, the first thing you mentioned, which is ID and then JSON, and that was it, instead of pulling out some of the columns that you might.
Right. Classic example here, if it's some account data, for example, which has email and so on, I would definitely put it as normal columns for better control, to have all constraints in place and to have better data quality, right? To ensure that everything is like field, not null, uniqueness, and so on. It can be achieved in JSON because we can have check constraints using some expressions over JSON, but it would be much harder to maintain.
Yeah, I think that might be an understatement. But yeah, I would not like to maintain a system that was doing that. But yeah, so constraints are a really good point. Good, like foreign keys are an example. Uniqueness. Oh yeah, so there's so many things that you're kind of losing out on nice support for.
You know what I remember from my XML practice 15 years ago when I worked on it for Postgres. Of course, there was several ways to ensure some like semi-structured schema for XML values. And for JSON, we don't have it. Of course, we can use some check constraints, as I mentioned. But there is an interesting project. I only know about it. I haven't looked at it. From Supabase, it's called PG JSON Schema. So there is something to ensure to have in place some schema for JSON and ensure that our values are matched against these the rules defined in this schema. So something interesting also. But for account data, for the data like billing data, I would never put the most important fields to JSON. I would keep them in relational part of tables.
Yeah, I've got a few more kind of reasons here as to why. Like, I think it's worth saying that, for example, if we want to update some of the data in there, it's hugely more expensive for some technical reasons, like especially if it's been toasted, if it's gone,
exactly the
off
toasting. It's not only about updating, but for updating, it's a big question, but also for reading as well. And all benchmarks which deal with which check different size JSON values of different size, we can observe that when we achieve toast point 2 kilobytes per or it can be controlled, right? In this case, degradation happens immediately, and then toasting adds huge overhead for both reading and modifications. But there is some work. I don't think it was finished and already committed. I think no. There is some work to improve the update speed, touching only those chunks of toast which really need to be touched. So this would be interesting improvement, but I think it's not yet finished.
Yeah, that would be cool, but I'm not sure how that would work, but that'd be very cool. The other a couple of other kind of more basic points that I think are quite important are, well, actually, Lawrence mentions joining. If you want to join on one of the columns, for example, that is in the JSON, that's obviously going to be a challenge. But I think the more important part for me, coming from the performance side, is there's no statistics on the data within JSON.
Yeah, and that's why joining can be not working well because of lack of statistics for internal data, right? Well,
so it's really difficult for the planner to make good decisions.
I suspect we can collect it, no? Using create statistic and expression, no?
You can do that?
Why not?
That would be cool.
well,
but it's not automatic, right? You'd have to do that on a manual basis,
right? But why not? It's just some fresh question came to my mind. I actually never needed it because I was very careful usually with JSONB values, keeping only some really flexible data there. So, and also worth mentioning, you might need to work with JSON even not storing any of JSON, right? You just provide it as output. For example, if you use Postgres, you do it all the time implicitly. You might do it explicitly if you have some queries. So relational data is stored, but JSON-B or JSON as output.
Oh, like casting to it. Or
right.
Or using a function, I guess, creating
or
it.
Parsing.
I never thought of it.
Or parsing. You take it as input and then you parse and store it as a relation. Actually, there's some direction of research called updatable XML views over relational data type, relational data. I guess it could be done for JSON as well. I'm not sure it's very practically interesting, but yeah. So you can have layers. So relational data stored and JSON as a communication language.
Yeah, true. And I think what you said just then is where a lot of people land with this is you're very sensible and stored a lot of it in regular columns. But then the kind of the more, you said the flexible part, the other way I've heard that described is fields where the vast majority of your rows would be null. Like if it's, I think a common example given is like an e-commerce store where you might want to store some data for some types of products that most products don't have that data for. So you want it structured, but it's mostly, for most of your objects, it's going to be null. So you could store maybe 5 attributes for each item, but they could be different for different items. So that, I think that'd be a really good use case.
Good. And speaking of nulls, you know how I love nulls. Of course, it's very important concept in all relational databases, but If you use JSON-B set to modify a part of your JSON value, you should be careful with nulls, because if you use relational null, SQL null, not relational, SQL null, in this case it will nullify whole value. You need to use JSON-B null, so it's like a string null converted to JSON-B. In this case, you'll be fine, and it will nullify only a part of your JSON value which you target at. So, yeah, and it's a lot of small things to learn when you work with it. But I think modern development is impossible without JSON, right? And any other pieces of advice you have?
No, you mentioned that the that toast value that
threshold.
it starts toasting things over threshold, yes, it can be configurable. That's, if anybody wants to look that up, that's the toast tuple target, and there's a really good blog post by Haki Benita where I learned about that, about storing medium-sized texts.
But
in
by
databases.
default, if we have JSON values much less in size than 2 kilobytes, we should be fine.
Well, much less, yes. If they're tiny, great.
Right.
If they're really big, there can be performance issues. But he actually makes a really good point that there's really weird performance penalties for medium size, so things that are just slightly under that 2 kilobyte limit. So yeah, it's a really good blog post, quite long, but I highly recommend reading it because it's quite counterintuitive.
As usual, I recommend experiment-oriented approach.
Yeah.
Take your schema, take your workload. If you don't have workload yet, try to invent it, trying to predict the future. It's sometimes possible. And just benchmark all aspects and pay attention to toasting and so on. Why not?
Absolutely. Anything else you had on your list?
I think no. I just wanted to mention that it's good, to learn. Like, I'm constantly learning. I don't know all the details. This reference of all functions related to JSON and JSON-B data types. An interesting thing that I use usually quite a lot. I use row to JSON and JSON AGG for aggregation. And the interesting small advice is that you can order by inside aggregation. So you can have group by, for example, and have JSON AGG, and there inside parentheses you write order by, and it works. For example,
that's so cool.
Yeah, it doesn't.
I didn't know
it's
that.
It's working independently from main order by clause in your select statement. So it's interesting.
Yeah. Well.
Actually, then, it's not. Sorry, it's about arrays. Then you can order by. Then for arrays, it's not fully related, but then you can also have indexing. For example, I want only first 5 members of this array. So, but a very important thing. New people sometimes make mistake here. If you use arrow operator, regular arrow operator for JSON and JSON-B values, you will be getting JSON or JSON-B values as a result. But sometimes you want text, and if you will see double quotes. If you later convert it to text, these double quotes will be preserved there, and it's not good. In this case, you one of the things I wish I knew earlier, right? Double arrow operator will directly convert it to text, eliminating double quotes. It's very handy.
Yeah, that's a great tip. Wow, some awesome little tips at the end as well. Bonus.
We can write an article now, right? JSON and JSON-B tips. Yep.
Yeah, that would be great. Oh, actually, there was one last blog post that I wanted to... So there's a couple of good ones, one by ScaleGrid that I'll share and one by the Heap team that I'll share as well. That were good and a bit of further reading.
And we should definitely share benchmark results from Oleg Bartonov's talks. Last was maybe a year ago or something. And sometimes there is a comparison with MongoDB there, also interesting. So, and speaking of MongoDB, there is a new project called FerretDB, right? Which is attempt to build MongoDB-like database system on top of Postgres, which is interesting. And
Yeah, is it compatible with Mongo?
I don't know details. I only know that one of the founders is Peter Zaitsev from Percona. So it's a lot of experience should be brought there, and I think it's an interesting project. I checked it yesterday. It looks very live, so a lot of development happening. So worth keeping an eye on it for those who have MongoDB preference in terms of work with JSON documents and so on. I'm curious about checking benchmarks for this new system. It's like open source MongoDB, because MongoDB is not really open source anymore, right? They push everyone to use Atlas, so this project has good chances to convert some users to Postgres, basically, right? So it's a good thing.
Yep, always. Wonderful. Well, thank you very much, Nikolai. Thank you, everybody, for joining us, and see you next week.
Thanks, Michael. Bye-bye.